Now we are on lecture 10, Design, Documentation, Unit Testing. So this covers sections 7 to 4, 5, 6, 7 from the textbook. Okay. Top-down design and bottom-up implementation. Before we write any portion of a large program, we should consider its overall design. We need to identify potential classes and the way in which objects from these classes will interact. A starting point is to envision the use of our final product and design, a top-level class and its interface. From there, we expand our design to include classes that the top-level class will need in order to perform its tasks. We repeat this process until we have designed a collection of individual components that can be written and tested independently. This approach is known as top-down design. Once the design is fixed, implementation should start at the lowest level and work up to the top level. This technique is known as bottom-up implementation. Every component must be tested thoroughly before moving on to the next higher level. So what does this mean? Suppose you have a large problem. It requires several classes. So you are going to design it from the highest level, break it into smaller and smaller pieces until you have a good idea of what all the small pieces you need to code. So you start designing from the topmost level until you have broken it down. And now when you're implementing, you start from the smallest pieces you wish to code. Okay? This might seem a bit abstract right now, so I will give you an example. Now this example will be, this paragraph talks about writing codes for classes. We will come to classes in one of our major projects, but right now let's look at using functions in top-down design and bottom-up implementation. So let me introduce you to a problem on racquetball. Okay, you want to simulate a racquetball problem. It is a sport played between two players using rackets to strike a ball in a four-walled court. To start a game, one of the players puts the ball into play. This is called serving. The players then alternate hitting the ball to keep it in play. This is called a rally. The rally ends when one of the players fails to hit a legal shot. The player who misses the shot loses the rally. Okay? If the server loses the rally, then the service passes to the other player. If the server wins the rally, then a point is awarded to the server. Players can only score points during their own service. The first player to reach 15 points wins the game. In our simulation, the ability level of the players will be represented by the probability that the player wins the rally when she serves. Okay, probability that you win a rally when you serve. Okay, that you need to give for each player. A player with probability 0.6 will win 60% of their serves. Okay, so the program must prompt the user to enter the service probability for both players and simulate multiple games of racquetball. Okay, so it's getting abstract already, right? So how do we implement or code such a game? So, detailed specification, the input should be program first prompts for and gets service probabilities for the two players, player A and player B. Then the program prompts for and gets the number of games to be simulated. So you want to know service probabilities for each player and the number of games to be simulated. In other words, what is the probability player A wins a serve? What is the probability player B wins a serve? And how many games to simulate? So the program must provide a series of initial prompts. Then the program should print out nicely formatted report. Game simulated 500. Say you gave 500, it should say 500. Number of wins for A, whatever. Number of B wins for B, whatever. All right, how many games? So this is what you need to give an output for. All right, so let's start. I have this rball racquetball.py file which I have uploaded in your Dropbox as well as Blackboard. All right, so we can look at this file and then see how it looks like. Okay, so notice this program, I have not written it. It is from the textbook titled Python Programming, 3rd edition, okay, by John Zell. So I have used his code. So he's from the random package, he's importing random function. All right. So he's defining what is called main function. You see, a program has several functions. Which function do you run? That function is called main function. So now, as stated, the problem looks very big, but your main function, define main, must have an introduction, printing introduction function, must ask for probability for A to win when A serves, probability for B to win when B serves, and N to be the number of games. So these three numbers are assigned some value that you will get from the user. So we need to define get inputs. Then you are going to define a function simulate n games with n as the input, probability for A, probability for, and you are going to see how many games A wins, how many games B wins. So we need to define a function simulate n games. And then finally with wins A and wins B, you are going to print summary with these numbers, wins A, wins B. I hope this is clear. So notice print info, get inputs, simulate n games, and print summary. These have not yet been defined. So let's define print intro. As of now, I have nothing. Define get inputs. As of now, I have nothing. So I'm just typing in pass. Define simulate n games. Okay. As of now, n prob A, prob B, I have nothing. And print summary, wins A, wins B, I have nothing. So I don't know what these functions look like, but I'm designing my code. So I've said my main function must give me an introduction. With that introduction, I must get input from the user, and then the input I receive, I must simulate n games, which will result in number of wins for each player, and then I must print the summary. So far I have nothing. So what does this line say? If double underscore name double underscore equal quotes main, that means when I compile this file as is, its name becomes main. Okay, it's a technical, um, uh, there is some technical background to it. We'll come to that later, if at all. But if name that you get is main, run invoke main function. That's what this is. Okay, the function main. So let me save it, run it. Invalid syntax. The invalid syntax is here because I should say define. Okay, so this was a good example of how I am testing whether the file so far works well. Okay, so this line is meant for unit testing, that I'm going to test each of these functions as I define. As you already saw, this got me to fix one of my lines in my code. So let's try running it again. Okay, cannot unpack non-type object. Okay, good. So I'm not able to do this because right now get inputs doesn't give me anything. All right, it's pass. So I'm unable to get anything going there. Okay, so that's good to know. It means I need to work on these. So let me stop my tape right now, video tape right now, and I'll come back to each piece now until the next one.